Hello everybody, in this video we are going to continue our conversation about simplifying polynomial expressions. This video in particular we're going to continue to talk about multiplying polynomials. Now in some of the previous videos we talked about how to do that using the distributive property, which looks very much like this, where we use our arrows to multiply the coefficients and then combine exponents on our variables. But we also talked about how we can use the box method, which is very similar but in organizing it in a different way. Just like anything that we've ever done, we've always had special solutions, special problems that kind of stand out from what we traditionally do with some of these problems. But multiplying polynomials is no different. So down here at the bottom of our notes, we have two examples here. We call them special factoring or special polynomials because they don't look, or the answers are a little bit slightly different than what we expect. So let's start with the one at the bottom. Now I'm going to continue to use the box method because I like how it's organized and it allows us to focus on each term individually. But you can continue to use the distributive property if that is the method that you prefer. So with this one right here, one of the common mistakes that I see when we see a problem like this on our paper is we want to square the 3, we want to square the x, and then we want to square the -6. And in this case, that's not necessarily true, because what a square tells us is that we're taking a particular number or an expression and we're multiplying it by itself. Let me give you an example here. If you were to see 5 squared, that automatically tells you that we're doing 5 times 5, because that's what the square means. And so the answer would be 25. And if you were to see something that says -3 squared, we know that we're multiplying -3 times itself, so -3 times -3, which would give us a +9. So when we think about it that way, just because we put a square on a number doesn't mean we can't do that and use the same logic with an expression. So anytime we see it in this section right here, we're going to take the entire expression, that 3x minus 6, and we're going to write it twice. So this actually becomes 3x minus 6 times 3x minus 6. And so from here, by taking this and writing it out like this, this now turns into a problem we've already done before. We've done a 2 by 2, and we've done it using the distributive property. So from here, I'm going to organize this into my 2 by 2 box, because there are 2 terms in the first one, 2 terms in the second one. So let me go ahead and create my box. Make sure that when you do create your box, you're leaving enough room so you can write inside each one of those boxes. So here are my 2 rows, here are my 2 columns, and then I'm going to keep my 2 terms on the same side. So right here, this 3x minus 6 need to go on the same side. And then the other 3x minus 6 will also go on the same side. So if they belong to the same parentheses, they need to stay together on the same side of our box. Now from here, we're going to go ahead and multiply this 3 by 3 and -6, and then I'm going to do the same thing with the -6. So 3 times 3 gives me 9, 2 x's, so x squared. 3 times -6 is -18, only 1 x between the two. And then we're going to multiply everything by -6. So here's -6 times 3, which gives us -18x. And then if I take my -6 and multiply it by another -6, a +36. Now as I'm multiplying, I include my signs. So if I have a negative number, make sure to include the negative, don't leave that off. And if it's positive, make sure to put the plus sign there, so that way when you organize it into our final answer and write it in standard form, you already have everything that you need. So let's write this in standard form. Notice that the highest exponent inside this box is a 2, and there's nobody to combine it with. So we're going to say 9x squared. If I look at my 2 diagonals, or my diagonal has 2 numbers, they both have x. And so from here, I'm just going to take my negative 18 and subtract 18 from it, which will give me negative 36. Bring down the x, and then our constant is 36. Okay? So not only did we multiply it, but we also combined like terms and wrote it in standard form, because it goes from the highest to the lowest exponent. All right, same thing here. Now, the only thing that's special about this one is that because we had to write the same parentheses twice, we ended up with a bunch of perfect squares. So this is a perfect square, this is a perfect square, and this is a result of these two numbers being combined. So notice how they're both exactly the same. Now this one is almost like the previous problem, except for one has a plus, the other one has a minus. So this one's already set up for us, so we're just going to go ahead and put it in our box. It is another 2 by 2. And here's my two rows, 2 columns. So we're going to keep each one of these parentheses together. So we're going to say 4r minus 8. Then we're going to say 4r plus 8. And then from here, it's going to look very familiar, but at the very end, you're going to notice something. So 4 times 4 gives us 16. Each one has 1 r, so when we bring it together, it has 2. 4 times 8 gives us a positive 32, 1r. Down here at the bottom, we're going to say 4 times negative 8, which gives us a negative 32, 1r. And then at the very end, we're going to do 8 times 8. One's plus, one's minus, so it's a negative 64. No r's on this one. Now, if I look at my diagonal, I do have like terms. I have a positive 32 and I have a negative 32. Pay particular attention to those signs, because notice how different it is here. Here we saw the two 18s, they were both negative, so we doubled them up. And that's how we got the negative 36. But here, even though I have 32 and 32, one's a positive, one's a negative. That's going to cancel each other out. That's going to become 0. And remember, if you have a 0, you don't have to write it out. But I'm actually going to write it out so you can see it. So we're going to say 16r squared plus 0r minus 64. And because this is a 0, our final answer would be 16r squared minus 64. So there's a big difference between having the same numbers, but one of them being the same sign. So both of these were negatives, while this was a negative and a positive. So you can kind of start predicting what's going to happen to these when you multiply them through. But that's it. That is our special polynomials, which if you know how to multiply them through, then you really don't, it doesn't need to stand out. You just need to be prepared for that answer to be 0 in the middle, which sometimes throws us off. But anyways, those are our 2 examples for special polynomials. I hoped that looking at those examples, setting them up, and working through them has helped you understand them a little bit better. So I will see you in the next videos.